In this video, we'll be going over functional stacks. If you're new to SST, stacks are simply a way to group related resources together and stay organized. Functional stacks are the new way to define stacks in SST 1.0 and going forward. So let's start by looking at the old method of defining stacks to understand some of the shortcomings and pain points that are addressed by functional stacks. So in the old method, everything was done using classes. So to define a new stack, you created a new class. So let's get started by importing the stack construct and creating a class called database stack that extends the stack construct. This class is going to contain all of our database related resources. And because everything is class based, you do all the work in the constructor. Every constructor always just took the SST app, and you have to make sure to call super with the stack ID. So this is a standard boilerplate you'll always need no matter what stack you're creating. So from here, you can create resources. So let's use the RDS construct to create a new RDS cluster. Let's give it a name, RDS. So this requires a default database name, which can just be my database, and the engine, which can just be Postgres for now. So that's all you need to define a database stack with an RDS cluster inside of it. But of course, there's not much that you can do with this. You need to pass the RDS cluster into something like a function that actually takes advantage of it. So let's define a new stack for our API. It's called API stack. And we'll set this up in the same way as a database stack. And we'll give this a different ID, API. So from here, we can use the SST API construct to create an API. And in this API, let's have a simple get route that is handled by a function. And let's say this function needs a default database name to do a database query to return the results. So we can pass that in the environment variable called database host. Cool. So the question is, how do we get this value here? So to get the value of the database host, we'll need to pass the RDS cluster from the database stack into the API stack. There's actually no official way of doing this, which is why this causes a lot of confusion. Everyone did it their own different way. We got a lot of questions about this from people that are first learning SST. It was a really common place where people got stuck. So what I personally did was I passed stacks into other stacks. So in this case, I would pass a database stack to the API stack. You can do this by defining extra props here. And this says to bring up the API stack, you not only need the app, you also need to pass in a database stack. So from here, you can access the database stack. You don't yet have access to the RDS cluster because you need to expose it properly in the database stack. To do that, you define a public variable. You have to manually define the type here, which is another pain point. And then you can assign the RDS cluster to that variable. And then if you go back into the API stack, now you can go into your props, go into database stack. You have access to the RDS cluster here. Go to the cluster endpoint and get the host name. Cool. So now you have two different stacks where the API stack is dependent on the database stack. We're not done here. We still need to coordinate these stacks getting loaded into each other. So you go into your main entry point. And let's first initialize a database stack. I'm going to assign this to a variable. And now let's initialize the API stack. So the API stack needs a database stack. So we can pass it in like so. Cool. So now this is all fully working. You can bring this up. The database stack will come up first. The API stack will reference the database host that we passed through. So this all works. The issue here is as your application gets more complicated, you're going to have a lot more stacks. You're going to have a lot more resources that are shared between the stacks. And the coordination in this file will start to get pretty messy. You'll have a lot of things in here. You have to make sure things get put up in the right order. You'll have to refactor this pretty frequently as you make changes. So now let's refactor this to take advantage of functional stacks. So just like class-based stacks use class to define stacks, functional stacks use functions to define stacks. So you can create the same database stack as before by creating a function instead. And functional stacks take a stack context. object. And then from here, you can start defining your resources. So let's once again create our RDS cluster, pass in the stack just like before. And let's create these props, engine, Postgres again. Cool. So this is all you need now to define a database stack. As you can see, it's less boilerplate than before. Well, let's go on and create our API stack. So we'll define another function. And then let's create our API. Cool. So now we have the same question as before. How do we pass in constructs from one stack into another? What's nice about functional stacks is in every stack, any construct you want to make public and potentially consumable by another stack, you can just return it. So let's return an object containing the RDS cluster. Now from here, we have a new use keyword that allows one stack to use resources from another stack. So let's define a variable called db, and let's use the database stack. From here, you have access to anything the database stack returns. So you can see the RDS cluster is right there. And we can now load this just like before into our simple function handler. RDS, default cluster endpoint, host name. All right. So what's nice about this is it's very composable. So if you add more things here, if your database stack gets more complex and there's more things you're exposing, you can just define it here. And it's all type safe. Everything is completely inferred, no manual types to define, and you just have access right there. If you remove something, you'll start to get errors that are helpful to track down what you need to update. So we still do need to load these stacks into our main index file, but it's a lot simpler. You don't have to really think about the dependencies between the two. So if you go back to our index file, let's delete all this. We have a new stack function on the app, and you can just load the stacks like so. And that's it. You're good to go. So this new approach, it's a lot cleaner. It's a lot simpler. As your app gets more complex, this file still stays pretty simple. You will have to list out the additional stacks you have, but the dependencies between them don't leak to this file. So to summarize, class stacks, you can still use them. They're still going to work the same way as before, but as I highlighted in this video, there are some shortcomings with them. Functional stacks make it easier to both define a stack and share resources in a type-safe way without having to really write any TypeScript. This is a pattern that we're going to encourage going forward. It's going to be in all our examples and our documentation. So definitely encourage you all to try it out and see if it clicks for you.